Alright, hello everybody. We're in section 1.2 and we're going to look at quadratic equations. So a quadratic equation is an equation equivalent to one of the form ax squared plus bx plus c equals 0. And here a, b, and c are real numbers, but a cannot be 0. So the natural question is, why can't a be 0? Why is this not allowed? And the answer is, if a was 0, that would cancel this term out and you'd have what? A linear equation. It's the square term which makes you have a quadratic. So that's the big key. You have to have an x squared in order to have a quadratic equation. Alright, there's many different ways to solve quadratics, and we're going to look at a bunch of them. So let's go over the types of ways to solve quadratic equations. So to solve quadratics, we can factor, we have the square root method, completing the square, and the quadratic formula. In this video, we're going to look at how to solve by factoring. But first, we need a very important property, which is called the zero product property. This is an important one. So zero product property. And it goes like this. A times b equals 0. So if you have an equation and you've got a product, it's not called the zero anything property, it's a zero product property. It's got to be multiplication. A times b equals 0, then a equals 0, or b equals 0. This is an extremely valuable property, very useful for especially for the factoring part. We need this property, and it's got to be multiplication. Alright, so let's try to solve some of these by factoring. Let me set up a problem here. Okay, so directions make sense. It says solve, and I have an equation. I have an equal sign stuck on both sides. And this is definitely a quadratic. We see that x squared right there. And we're going to solve this by factoring. To solve by factoring, there's one thing that is very, very, very important. To solve a quadratic by factoring, the equation must be set equal to 0. So underline, million exclamation marks, very, very, very important. Because we're going to use the zero product property. It has to be equal to 0. So this guy's set. I'm going to go ahead and factor. This is your classic trinomial with leading coefficient of 1. I take minus 20. I'm looking for two numbers, multiply to minus 20 and add to minus 1. I think minus 4 and 5 will do it. Since it's got that leading coefficient of 1, we've got our factors. And what have we done? We've created a product. And now I can use the zero product property. This is like our A and this is our B. So now I can set each equal to 0 and solve. And we get our solutions of 5 and minus 4. And it's an equation, so of course you can plug back in and check and make sure it works. These both will. But it should make sense that when linears, we usually get like one solution. When you get x squared, most of the time you get two solutions. Sometimes you only get one, and sometimes you don't get any. But here we get two solutions, and that's pretty standard. Alright, let's take a look at another example. Okay, solve. I've got x squared, I've got a quadratic, I've got an equal sign, I've got an equation, we're all set. So, alright, I'm going to factor in x out, with x minus 4 equals 12. Then I get x equals 12 and x minus 4 equals 12. Add 4, and I get x equals 16. And what happened here? This is a big no. Can't do it that way. Why not? Because we need it to be equal to 0. So watch out for that. Must equal 0 if we're going to solve this by factoring. Watch out for that though. It's tempting to do this and you're not going to get answers that work unless it's by pure luck. We're using the zero product property, not the anything product property. It's got to be equal to 0. Must equal 0. Alright, so let me erase this garbage answer because it's giving me a headache just looking at this wrong work, and let's do it the right way. Okay, so the first thing, we're going to move that 12 over. Subtract 12 both sides. These are all unlike terms. X squared minus 4x minus 12 is 0. And now I can factor. Trinomial leading coefficient of 1. So I think if I take minus 12, looking for two numbers, multiply minus 12, add to the minus 4. Minus 6 and 2 should do it. Minus 6, positive 2. And now I've got equal to 0. And now I can find my solutions, which are x equals 6. And subtract 2, x equals minus 2. And we got it. Alright, one more. Alright, let's try this one. So definitely have a quadratic. There's my x squared term. I got an equal sign. I got stuff on both sides, and it equals 0 already, so I don't have to move anything over. I'll go ahead and solve this by factoring. So remember, here you have a general trinomial. It doesn't have that leading coefficient 1. So take the leading coefficient and the constant term and multiply them together. We're looking for two numbers. Multiply minus 6, add to minus 5. It's going to be minus 6 and 1. Break up the middle term. 6x plus 1x minus 3 equals 0. And now we're going to do grouping. So the first two terms, greatest common factor is 2x. Pull that out, leaves me with x minus 3. And you always have to take something out of these two. So it already matches this term that we want. So this is a common trick where if you don't want to change this at all, always take out a positive 1. X minus 3 equals 0. Finish off the factoring here. Don't start setting it equal to 0. Finish the factoring. It's a common mistake I see. Because you don't even have a product yet. You've still got like addition running around the middle. So then x minus 3 comes out. 2x plus 1 equals 0. Now I can do that 0 product property. Alright, need some more room here. Okay, so I set the x minus 3 equals 0. I turn a quadratic into two simple linears. Get our first solution of x equals 3. And I set the other term equal to 0. Move the 1 over first. Get that x term by itself. And then divide by 2. And we got it. We got our two answers. Plug back into the original and check, but this should work out. Alright, that's solving by factoring. Next video, solving by square root.